How are you, my friends? This video is presenting 16 solved review questions for Algebra course lectures 1 to 12. There is another 15 solved review questions for the same lectures 1 to 12. If you want to see the lectures themselves, you can go please to a playlist called Algebra course lectures. But these review questions, you can find them in the playlist called Review Questions. Let's start question number 1. Look at the nice question here. We have rational exponents. We have exponent in the power 0, something like that. You can try this for a few seconds or 1 minute or so, then you can see the answer. We have to play with the numbers. We can see here 3 terms, this one plus this one plus this one. We can simplify each one separate, and let's see the value. Now the first one, 27 over 8 to the power minus 2 over 3. 27 over 8 is 3 over 2 all cubed. See the power here, cubed, 27, 3 cubed, 8, 2 cubed. Now you multiply the powers here. 3 times minus 2 over 3. You cancel the 3, we are left with only minus 2. Let's continue with the first one. 3 over 2 is a fraction, and there is a power minus 2. The minus will flip the fraction, so it's 2 over 3, square it. See the minus 2 in the power, minus flipping the fraction, 2, we square it. So the first term here, always it will go to 4 over 9. Let's see the second one. 9, 3 squared, same idea. Multiply the powers, 2 times 3 over 7. It will be 6 over 7. And here 81, see this minus not in the base, you can see that? This minus not in the base. There is no bracket here, be careful. So the minus can go outside, see this minus here, it will go outside in the middle. 3 to the power 4, all to the power 1 over 8. When you multiply 4 times 1 over 8, it will be 1 over 7. See here we see the same base, we can add the powers, 6 plus 1 over 7, which is 7 over 7. So that's 1. 3 power 1. The LCD here we can see 9. So I multiply, this is 3, multiplied by 9, so up will be 27. And this one, 3x in the base, 3x with the power 0, that's 1. So it's 5 over 3, it will go down, multiply by 3 to make it 9. So that's 15. 4 minus 27 plus 15. So 19 minus 27. The final answer is minus 8 over 9 with little nice colors. Let's see question 2. If 1.377777, you see this one is repeating. That's a repeating decimal. 1.3, 3 is not repeating, the 7 is repeating. 1.37777, that's a rational number. Let's call it m over n in simplest form after you simplify it. And let's find m minus n so that the answer will be one number. This is like exam type. Let's see. So I start for sure with this number 1.37777 or 1.37 dash. Let's call it this one x. See? Forget now for a few moments about mn. Let's go to this number. Let x be this number. See, I have 3 here. So I multiply by 10. So 10x will be 13.7777. Let's call this equation 1. Now, the repeating part is also one number, which is 77. It can be 2 numbers. If it is one number, we multiply by 10 again. So 137.777, we call this equation 2. Now, if you need to see more examples about these repeating decimals, how to convert to fractions, you can go, there is a video called how to convert repeating decimals to fractions. So let's take now equation 2 minus equation 1, which is 100x minus 10x, 1.37.7 dash minus 13.7 dash. So it will be 100x minus 10x. 90x is equal 124. No decimals, they will all cancel out. Now, x will be 124 over 90. Divide by 2 to make it the simplest form. 62 divided by 45. So this is m, this is n. M minus n, 62 minus 45, and the answer is 17. Question number 2. Let's see question number 3. We have here a union and intersection. Let u, x such that x is a whole number less than or equal to 7. A is another set, x such that x is an integer number between 4 and 8. B, set B, x such that x is an odd prime number less than 10. We need two things here, please. List all the elements of the sets U, A, and B. So list the elements in the U, elements in the A, elements in the B. Then find B union A intersection A prime. A prime means the complement. If you want to see also more about these, you can go to real numbers, intersections, and unions. Let's see the answer here. Also, you can try if you like. This is a nice question. So what are the elements in U? What are the elements in A? What are the elements in B? So U, 0, 1, 2, 3, 4, 5, 6, 7. It's less than or equal to 7. You can see that here, less than or equal to 7. Whole number, so 0 is there. A, integer number between 4 and 8. So 5, 6, 7. And B is an odd prime. 1 is not counted there. 3, 5, and 7, because 1 is not a prime. Prime is after 1. A prime now, A prime means all the elements in U, not in A. So A prime is 0, 1, 2, 3, 4. Let's find B union A. So this is B and A. If you find the union, it's 3, 5, 6, and 7. Now this is B union A, intersection with A prime in the green here. Find the intersection, 3, 5, 6, 7, intersection 0, 1, 2, 3, 4. The answer is a set that contains only number 3, 1 element. Let's see number 4, very nice question. This is on the thumb. Simplify all this. You see this is a power here. Minus, 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 square root of 25. 25 is inside. You have to distribute here because we have multiplication. So we can distribute the power. Also, we can distribute here the power. And the answer is so simple and neat. 5y. We can see here, if we go in details, see I put here all the formulas that you might use, the rules of exponents, everything you need in this nice question. Square root of 25 is only 5. 5 squared, the power 2 here multiplied by this. We can distribute the power, a, b to the power n, a to the power n, b to the power n. We have here two numbers, a and b. So 5 power 2 times minus 3 over 2, so it will be power minus 3. X is the same. Y we leave it. Down we have three numbers here. 5 to the power minus 3, x to the power minus 3, y, 8 over 9 times the minus 3 will be minus 8 over 3. Now we can cancel 5 power minus 3. We can cancel x to the power minus 3. 5 is there. Y over y, see we have different power. Use this formula. A to the power m over a to the power n is equal to a to the power m minus n. Actually, we did not use this formula here. A to the m times a to the n is equal a to the m plus n. You can use it anytime if you multiply with the same base. So I put this as an extra here, just little gift. So we have y, now we subtract the power here, minus 5 over 3, minus 8, so it will be plus 8 over 3. So it will be power 1. So 5y is the answer. Okay, let's go. Question number 5, factor completely. See, we factored many questions If you need to see more lectures about factoring, you can go to lecture 10, 11, and 12. So usually here, when we have rational numbers, fractions, or integers, we take the smallest power in the common, the smallest power. See, x minus 1 is the base here. Now, let's see. Take x minus 1, see, take the smallest exponent here, minus 3 over 2. So what do we do here? We write x minus 1 to the power half, which is the given here, minus the power outside. This is like we divide this by this. Now, plus here, see, plus x minus 1, power minus half, minus the power outside. We did many questions like this. Minus x, we leave it. See, minus x, we leave it. X minus 1, we have minus 3 over 2, minus the power out. So look here, the last one, minus 3 over 2 plus 3 over 2 will be 0. X power 0 is 1. So x minus 1 here, power 0, that's 1 here. So 1 times the x is this x. You see, that one will disappear. Now, let's continue here. Half minus minus 3 over 2. So it will be 4 over 2 squared here, x minus 1 squared. I can use the formula. I think you remember the perfect squared. X squared minus 2x plus 1. And this one minus half minus minus 3 over 2, which will be 3 minus 1, 2 over 2, which is 1. So the first three terms here, see, x squared minus 2x plus 1 from this, x minus 1 in the middle, and the last one is minus x. Let's see here, what do we have in the bracket? Minus 1 plus 1, they cancel. Minus x plus x, they cancel. So we are left with x squared minus 2x. We can see here, we cannot stop here, because in the factoring, we always ask, can we factor more? Can we factor more? So take x as a common factor. So the final answer will be x minus 1 to the power minus 3 over 2, x minus 2 when you take x out. Question number 6 is a little nice here. Find k if the coefficient of x cubed in the product, this is the product, this is a polynomial, is 41. So the coefficient is 41. We need k. What is k? That will make the coefficient 41. The coefficient, remember, of x cubed. So we don't care about x squared. We don't care about x or x power 4. So I try to multiply here by using smart way. See, this is something times x minus 1 squared plus x cubed. There is a term here. So first I simplify this, x minus 1 squared expanded, and then multiply by this to see what will result in x cubed. So to make things easy, I leave the x cubed. You see this one here? I leave it. Minus 5x, I multiply, distribute inside this one, small bracket, the binomial. So minus 20x plus 5kx squared. You see the first one only, the first two here. And this is a formula, x minus 1 squared. We know that. X squared minus 2x plus 1. Now, where is x cubed? If I multiply the x with the squared, that will give me cubed. So only we need the cube. So minus 20 here. This one with this one will give me cube. So minus 10k x cubed plus x cubed. It's already there in the question. So if I take x cubed out, that will be minus 20 plus 1 here, you see. Minus 20x cubed plus 1 will be minus 19. And then minus 10k, that's the coefficient here, is equal to 41. So you take minus 19 on the other side, 60. 60 divided by minus 10 is minus 6. This is the k. Just review this nice question. So the whole idea is about coefficient. We can multiply all this, but it will take time because we need only cube. So I see where is the cube. Okay. Perform the indicated operations. That means multiply, subtract, add, whatever you have to do, do the operations here. I start here in the cube. See, this is a cube. That's a formula. we have like x minus y all cubed. We will see the formula now. Here we can multiply the binomials. You can use FOIL method or multiply term by term and then distribute a to the power x. The answer is simple, I think, here. If you want to try, you can pause the video a little. You try it and then you check your answer. Now, the final answer is simple, as I said, minus 7a to the power x plus 1. Almost everything will cancel, almost. Let's see here. Multiply this one by the FOIL. So a power x, we leave it. A power x times a power x, we add the power, a power 2x. A power x times 1 plus a power x, minus 4 a power x, minus 4, 1 is minus 4. Now leave the minus. In the cube, when you have x minus y all cubed, there is a formula, I think you remember that, cube of a difference. You cube the first one, so a power 3x, minus 3 a squared b, so this is a squared and b, so a power 2x, plus 3a to the power x, minus 1 times minus 1 times minus 1 is minus 1. Now here we distribute this one, a to the power, maybe you can add here first, yes, you can distribute at the end, a to the power x minus 4a to the power x minus 3a, to make it simple. Then you can distribute a to the power 3x minus 3a to the power 2x minus 4a to the power x. And here we change all the signs because we have a minus at the beginning in the question. This is a minus, this is a plus, this is a minus, this is a plus. Now we see which things cancel. Everything power 3x will cancel. See, this is the green here. Everything with power 2x, it will cancel. This one we add, it's minus 7, a to the power x plus 1. That's the answer. Okay, number 8. Now, boy, we have two terms here with radicals, cube root, fourth root, square root. Multiply and add, there are two terms here, and then the final answer, make it m square root of 5 over n in simplest form. Then find m times, and you take the numbers here. This is like exam type. So for sure here, we leave this m and n, take the left side and simplify each number until you get the final answer similar to the right side. Let's see. I think everything is easy here, like square root of 5 is already simplified, cube root of 16, cube root of minus 8. This one you have to simplify. This is not easy. Fourth root of 4. I think you have seen it somewhere, even in the lectures. You can go to radicals, algebra lectures and radicals. Now let's see. Simplify 3. Cube root of the 16, I make it 8 times 2. So this is the yellow stuff here. 8 times 2. Cube root of minus 8, directly it will be minus 2. It's minus 2, minus 2, minus 2. 54, I make it 27 times 2. And this is square root of 5. Now, fourth root of 4, you can do the 4 here, 2 squared. 2 squared, you see this 4? 2 squared. 2 to the power 2 multiplied by 1 over 4, 2 power half, so square root of 2. This will be square root of 2 here. So we cancel that with the square root of 2. So the second one will be square root of 5 over 1. Now the first, we have many numbers there. The cube root of 2 will cancel. 3 will cancel here. There is a minus, 2 and 2 is 4. So what we have here, minus 4 over square root of 5, be careful please, minus square root of 5 over 1. This is what you get here. So suppose we have square root of 5 up and down to make LCD, square root of 5, minus 4, minus 5. So multiply up and down by square root of 5. So you get minus 9 square root of 5. Then you rationalize. So minus 9 square root of 5 over 5. Now you compare with this, you see, m square root of 5, this is m over n. So the m directly will be minus 9 and the n is 5. When you multiply, you get minus 45. You can review this nice question. Maybe few ideas are there. Question number 9, we'll come back to the factoring. Factor the binomials completely. There is one question similar to this in lecture, I think, number 10. Algebra course, lecture number 10. It's easy now. We have here two terms, so we can see the common. See here we have 100 m power 4. So we can see there is a common inside. This is the trick here. 5 is the common inside. You see 5 and there is m. G is not a common, n is not a common. So I cannot take out here 5 and m because we have squared. So when you take it out, you have to square it. That's the trick. If you have seen this idea. Look here. That's the question. Common factor 5m inside the bracket. That's the little trick here. So 5m, you see 5m, g minus 3n inside the bracket. See with the squared outside, the big bracket. So now you can say, second point here, x times y times z. If you have squared or any power, since we have only a multiplication, it will be x squared, y squared, z squared. Now x in our question is 5 here, and this y is m, and this z is g minus 3n. So you square each one, 5 squared, m squared, g minus 3n squared. You see that? That's the trick in the question. Take a common factor inside the bracket and square it. So it will be 25 m squared here, g minus 3n squared. Now the 100 m squared, I have to make the same term here, 25 m squared times 4 m squared. So I split the 100 into 25 times 4 and m power 4 into m squared. Now I have another common factor here, you see? 25 m squared, here we have 25 m squared, take it out. And then big bracket we have g minus 3n squared minus 4m squared. Now 4m squared, I can play with the number here and make it 2m bracket all squared. I use this blue, x squared minus y squared, x minus y, x plus y. So this will be g minus 3n, this is x and x, minus and plus. That's the final nice answer. Okay, question number 10. It's not difficult, but it looks ugly. Simplify the expression. We have many radicals, up and down. You can multiply, you can try. The answer is very, very, very simple. You cannot believe the answer. The answer is only h. No fractions, no numbers, only h. Okay. What can you see here? See, this is the difference between two squares. Also, this is the difference between two squares. It's given that h positive, so don't have to worry about absolute value. That's the only formula used here. The x minus y, x plus y will be x squared minus y squared, up and down. See, up here we squared the first one, minus, squared the second one. Leave the 4. See, the 4 we leave it. This two brackets, h, square root of h, all squared, minus 2 squared. The first one, when you square this one, you get h squared plus 9, and there is minus 9. And here we have the 4 from the beginning. Square root of h squared is h, minus 2 squared is 4. So the 4 here will cancel, the 9 will cancel. H squared over h is 1h, green h. Number 10. Number 11, we come back to the factoring. Factor the expression completely. Factoring is one major important topic in algebra. W squared plus WT minus 12T squared plus 7W minus 21T. What do you think here? We have 5 terms. 5 terms, guys. Usually we have 2, we have 3, now 5. Anytime you have 4 or 5 or 6, 4 or more, you have to think of grouping. Grouping, you take the terms that are related. that we can factor. Look here, please, just looking. What do you think? You can switch the terms. As you can take this one here, you can take number 2, you can turn number 3 up. It's all normal. So I can see the first 3 terms, because we have w squared, t squared, this is wt, we can factor these 3 trinomial. And here we see there is a common, see, 7w minus 21t. So I will do that, 3 and 2. So say factoring by grouping, 3 by 2. So I take the first 3, I write the first 3, and then I write the last 2. This is a trinomial, so that's easy. W squared, wt minus 12. So this is easy. W minus 3t, w plus 4t, the first 2 here. Okay, so these 2 factors for the first term. If you multiply w squared, w4t minus 3wt, so this is plus and then minus 12. It's easy. Now this is only a common factor, 7. See, we see here now, w minus 3t is common. You see, if you have dy plus 7y, see, remember, I put simple example here in the yellow. dy plus 7y, why is this a common? You see y common out. That's easy to see. D in the bracket plus 7, that's the same here. See, the 7 is there. D is this one. See, D is w plus 4t. And the y, instead of the y, we have w minus 3t. See, same, that is y and y. Take it out. And this is d now, w plus 4t plus 7. This is like d plus 7. This is easy. This is not easy. Easy, not easy. Now let's see, this is question number 12. Oh boy. I wrote here nice question. It is really nice because we have 6 terms. 6 terms, any number of terms more than 4 will be by grouping. So you have to see which terms are related. So we can see here 2x minus 2y. I can see the first 3, leave the 8. Let's see. Now if I take, this is 6 terms as I said, take 3, 2, and 1. If I take the first 3 terms, I just throw them here, take 3 common, x squared minus 2xy plus y squared. That's easy. Now this one is complete or perfect because we can use this formula, a squared minus 2ab plus b squared is a minus b squared. So we leave this one for the first 3 terms. Now in the 2, I take a common factor, you see here, so 2x minus y, leave minus 8. Now I can change the variable here. This is a little idea, simple idea, to make it simple. So I put x minus y, let x minus y or t is equal x minus y. So I have 3t squared plus 2t minus 8. This is a trinomial. See, instead of 6 terms, now I have 3 terms, easy to factor. 3t and t, when you multiply, you get 3t squared minus 4 and 2 plus, that's 6 minus 4 is plus 2. Now I put back the value of the t. I cannot leave it here. So the t is x minus y. So this will be 3x minus 3y minus 4. And this is only t, x minus y plus 2. Let's look now at question number 13. This is exam type. Find the sum of the factors of the expression. See, we have also 6 terms here. And we need to find the sum. That means we have to add something. What are these something? The factors of this, which means factor it first. After you finish, maybe the answer has 2 factors or 3 factors or 4 factors. You add them. Now, if you remember, this is exactly the same question. If we go back a little, question 12, you see, we already factored question number 12. So, instead of factoring again, I will make a copy. So you get the idea now? From question number 12, the complete factoring for this expression is given by this. 3x minus 3y minus 4, we did that. See the solution of question number 12. X minus y plus 2. This is the factoring here. In our question, in question 13, look at the question. Find the sum. So you have to do one more thing. You have to find the sum of the factors. You take this factor, you add another factor, you add them, just normal addition, like terms. 3x and x, 4x, minus 3y minus y is minus 4y, minus 4 plus 2 is minus 2. This is the sum of the factors. This is the factoring. I can tell you why maybe in the exam they do like this, because if this is the answer in the exam and there is a multiple choice, then you cannot know the factoring. So you have to factor it, so they hide the factoring. If you give me the answer here as a multiple choice, you can multiply them quickly to get the answer, so you know which is the correct one. But if they say find the sum or something, that means they hide the answer. Let's go here. 14 is, I think, nice question. Simplify the expression. We can see here 4 radicals. Square root of 2, the easiest one. We cannot do anything there. 7th root, 8th root, the index here. The important idea in this question is the index. See, this 7 is the index. 8 is the index. 4 is the index. This is easy. All right. Now, if you have odd or evens, there's a difference. In the odd, we take the number out. If this is 7th root of 8 to the 7, the answer is A. 8th root, you have to take the absolute value if you have the same power 8 for sure. So, oh boy, look at these colors. My goodness. So the first one here, this is an odd. Odd, see, the nth root of A to the n is A. So I just put minus 8 because 7th root. Now 8th root, I have to put absolute value of 1 minus square root of 2. Where is that here? N is even, the index, nth root of A to the n. So this is the second one. 0.0081, this is 81 over 10,000. See, instead of this, I can write fraction. That's easy. 81 divided by 10,000, which is 3 power 4 divided by 10 power 4. And we have 4th root, and these are constants. So there is no need for absolute value. So this is 3 over 10. Now, minus 8. Oh, another thing here. Absolute value 1 minus square root of 2. Is this positive or negative? This is a negative number because square root of 2 is 1.4. So you have to put a minus before that to make sure it's a positive answer. See this here, we have to put a minus. So now minus 8, minus 1, plus this, minus this, they will cancel. So we get minus 9 over 1 for sure. And this one 3 over 10. I can use this formula here. If we divide 2 fractions, division of 2 fractions, use the reciprocal. So sometimes we call this RDF, depends, using the reciprocals to divide the fractions. So minus 9 over 1 times 10 over 3, when you cancel it by 3, you get minus 30 is the answer for this question number 14. This nice question, the answer is minus 30. Factoring again, question number 15. Factor the expression completely. Now here you have to be careful. We have numbers in the common here. We have numbers, fractions. We have the x and x squared. We have 7x minus 2. This is all the base with different powers, 1/3 minus 2/3. We take the smallest. Even x squared than x, we take the smallest power. And we take 1 over 3 common. You see, 13 over 3, 1 over 3. So I can take out 1 over 3 and also x. Also this one with the smallest power. Let's see how the answer will look like. Let's see. So 1 over 3 is common. See, 1 over 3, I take it out. And there is x also common. See, x out. X out, that means I will leave here 1x. You see this x? And the 13 also is inside. So the 1 over 3 went outside in the common factor, 1/3, also x. 7x minus 2 with the smallest power, minus 2 over 3. So as we said before, 7x minus 2 will be 1 over 3 minus the power outside. Now 13x, 7x minus 2, minus 2 over 3 minus the power outside. So this will be power 0. See 7x minus 2 power 0, that's 1 here. See this 1. So the only thing here we have 13x. 1 over 3 minus 2 over 3 will be 3 over 3, 1. So 7x minus 2 plus 13x. So what is that? 7x, 13x, 20x minus 2. See, 2 is a common factor here. So take 2 out, out. It will be 2x over 3, 7x minus 2 to the power minus 2 over 3. In the bracket, we have 10x minus 1 when you take 2 out. And the last question in this review, find the value of this expression. Square root of 3, this one squared, minus this one power 4, plus 5th root of 32. It's not that difficult. It's like a gift at the end of the day. So this is 16 review questions. You have another video, 15 review questions. Only these 31 questions for the lectures, algebra course lectures, from 1 to 12. Later, when you see the other lectures, you can see other review questions. Now let's simplify. I think we start here in the power 2. We know the formula. That's the formula. The yellow here directly waiting for us. A plus B squared. A squared plus 2AB plus B squared. So this one here, we squared this one 3. 2 times the 1 times the 2 square root of 3 plus 1 minus. See this one, 2 square root of 2. I can make it square root of 8 so that I can multiply the indices here. 2 and 2, I can multiply the indices. So I bring the 2 inside here, becomes square root of 8. Leave the power 4. Square root of 30, fifth root, this is fifth root of 32 is 2. We know that, 2 power 5. This one we add here. 4 plus 1, that's easy. 4 plus 3 plus 1 is 4 times this one, 4. And this one, square root of 3 is 3 times 2, that's 6. And this one, multiply the indices, 4th root of 8 to the power 4 plus 2. This is the 5th root of 32. Now this one will be the minus 8. See the minus outside here from the question, 8. So 6 and 2 is 8, and this is minus, so it will go. So to find an answer for square root of 3. Big question. The answer is short, little, easy, and nice. 4 square root of 3. Thank you for watching. If you like these review questions, you can subscribe, share it with your friends, and see you in another video with another topic. Thank you very much.